So we're going to be talking about the different laws of exponents. So it's not a specific section, but it does help us get to understand some of the other sections. So we're going to start right away with your VIX and ignore vocab terms, but you do need to know what an exponent is, which is a power, and you also need to know that this bottom piece here is considered to be the base. When you talk about the different laws, we have 5 that we want to focus on. If you are multiplying with the same base, you're going to add the exponents. So the base stays the same, and I just add the exponents. It might be something like x squared times x to the third is equal to x to the 2 plus 3, which would be x to the 5th. If we had a power to a power, this is called, where you have one power raised to another power, here we multiply. So if we're adding with the same base, we're multiplying with the same base, we add. If we have a power to a power, this is where we actually multiply. If we are dividing, we want to subtract the 2 exponents. Anything raised to a 0 power is 1. Anytime you have a negative exponent, you want to make sure that you switch it. So what I mean by switching it is if it's in the denominator, it's going to come to the numerator. If it's in the numerator, it's going to come to the denominator. So x to the negative a really turns out to be now in the denominator with a positive exponent, and it's underneath 1. So it's 1 over x to the a. So some of the examples that we're going to go through start off a little simpler, and then we'll get some more complicated. But we're going to simplify 2k to the 4th times 4k. Just as you normally would, you would multiply those values of 2 times 4, which gives you 8. And k to the 4th times k, since that really has a power of 1, we write it as that there's 4k's here and 1k here for a total of 5k's, which is k to the 5th. 2x squared to the negative 4th. Well, notice that you have a power to a power, so you want to multiply, but you have to make sure that you would also distribute that. There's a 1 here. Before you go through and distribute that, we want to change this whole thing down to the denominator because we no longer want it to be a negative exponent. So now this turns into a positive exponent on the bottom. This 4 does get distributed to each of the 2 and the x. You treat it as its own separate thing. So every variable is going to be different. Every number is going to be different. So 2 to the 4th is 16, and x squared times 4 is x to the 8th. Because again, power to power, you multiply. From here to simplify, notice that you have a negative here. There's nothing to distribute, but you do want to make sure that even though this exponent is negative, it doesn't have anything to do with the 3. The 3 is its own separate thing. So the 3 would stay in the numerator, and this m to the negative 4th moves to the denominator to now become positive m to the 4th. Because they have the same base, we add the exponents. So the 3 stays up top, and we have m to the 7th over here. For the last 2 examples, it looks like a lot, but we have a fraction where you have 6/15, x squared and x to the 7th, y to the negative 3rd and y to the 5th, and z to the negative 2nd. Now the reason why I read that separately is because you want to make sure that you take each of those separate. So 6/15 you can simplify on your own. 6/15 they both share a 3, so that simplifies to 2/5. X squared and x to the 7th, you have 2 x's up top, 7 x's on the bottom, so you want to subtract your powers. If you bring the 7 up, it's 2 minus 7, which would be to the negative 5th. Well, we don't want negative exponents, so try it the other way. So you'd have 7 minus 2 leaves you with 5 x's on the bottom. For the y's, because this is negative, I want to move it to the denominator, and I would add 3 more to the 5 that were already there. So that gives you your y to the 8th. And this z to the negative 2, I'm going to bring up to the top, so now it's a positive z squared, and I have 1 here already, which gives me a total of 3 z's, or z to the 3rd. The last one says simplify as well. That's what we've been doing. And you have 2x cubed y to the 4th all squared times x to the 5th y all raised to the negative 3rd. So distributing this out for each of these separately, you have 2 to the 2nd, because there's an imaginary 1 there. So 2 to the 2nd is 4. You have x to the 6th, which is why there's an x to the 6th, and y to the 8th, which is why there's a y to the 8th. You also have x to the negative 15th, y to the negative 3rd. But if they're negative values, you want to bring them to the denominator. So x to the negative 15th now gets moved to the denominator to be x to the positive 15th. And y to the negative third, because again, there's a 1 times negative 3 is negative 3, which moving it to the denominator becomes a positive 3. Lastly, you want to look to see if there's anything that's the same. So the 4, and there's a 1 here that can't be simplified any further, so that's 4. You have x to the 6th and x to the 15th, which simplifies to be x to the 9th. You're going to be subtracting those powers now in your denominator. And y to the 5th, because there's 8 up top, 3 on the bottom, and 8 minus 3 is equal to 5.